Okay, we got 6 new formulas you need to memorize. Add them to your sheet of paper in front of your binder with all the formulas that you're going to collect for this chapter, also found on page 416 if you want a quick reference guide. These are all formulas that are compound angle formulas. Usually I show you how they're derived for the video. I don't have any time for that, but they're basically, one terminal arm, another terminal arm. The compound angle is the middle angle, right? If we're subtracting the 2 angles. And we can use different formulas like, I don't know how to cross my arms like that. The distance between my hands with that little angle in there, we can use cosine law and we can use substitution and actually derive these formulas. But we're not doing that for today. So memorize these formulas and we're gonna learn how to use these formulas. So these are super useful because they allow us to find the exact values of different numbers, right? We know the exact value of 30, 45, 60, 90, and all multiples of those numbers because of the special triangles. But now if we can turn 15 into a compound angle of 2 special angles, then we can find that actual angle as well.
Please come to main office.
So I can change cos of 15 into cos of 45 minus 30. Okay, so now I have a compound angle 45 minus 30. I can see which formula it is. I'm doing cos, of a minus b. So I'm going to write down cos of a, cos of b, plus sine a, sine b. Okay, so the first angle is my a angle, the second one's b, and I'm just substituting into the formula. Now that I have it separated like this, I know the exact value of cos of 45, it's root 2 over 2. I know the exact value of cos 30, it's root 3 over 2. Sine of 45, root 2 over 2. Sine of 30, 1 over 2. Okay, very useful to have all your special angles memorized. Very useful. This becomes root 6 over 4. And this is root 2 over 2. Sorry, over 4. And this becomes, just going to do it over here for space, root 6 plus root 2 all over 4, and this is my final answer. That is the exact value of cos 15. There's no roots in my denominator. Why? Because I use root 2 over 2 instead of 1 over root 2. If you're using 1 over root 2 like you get from your special angles, you're going to have a root in the denominator, and we're going to have to simplify that. But you're going to see that more in the next example. Okay, pretty easy with degrees. We know that 15 is a 45 minus a 30. It's pretty straightforward, but we lack some fraction skills. So sometimes when we have radians, it's hard for us to come up with a compound angle, but it's not that hard. When you're dealing with fractions and you want to split it up, you're only really splitting up the numerator, right? Because you can't split up a denominator. Everything's in 12ths. So the negative 5 needs to split up into like a negative 1 and a negative 4, or a 2 and a 3. 1 doesn't make any sense because I'm going to have 1 over 12. And that's not a special angle. Okay, so if I split up the negative 5, I can rewrite this as negative 2 pi minus 3 pi, and they're both over 12. Okay, it's really easy to split it up. I'm just doing the angle here. You only want to split it up into a number that's going to reduce, because we don't know 12ths as special angles. We know 6s, we know thirds, we know halves, we know fourths, so you have to turn it into those. But don't think of getting there in one step. Just break up the denominator into something that is a factor of 12. So 1 and a 4 doesn't work, even though a 4 does, the 1 doesn't. And this is now going to reduce to tan of negative pi over 6 minus pi over 4. Okay, so I broke it down into my negative pi over 6 and my positive pi over 4 if you're thinking of subtraction. So I'm using this formula down here with my subtraction of tan. I'm going to say tan of a, which is negative pi over 6, minus tan of b, which is pi over 4. It's positive pi over 4 because I'm using the subtraction formula, all over 1 plus tan of negative pi over 6 times tan of pi over 4. That's my first step. Now, tan of negative pi over 6 is going to be here. That's negative pi over 6. So I know tan is going to be negative there. Pi over 6 is root 3 over 3, so it's going to be negative root 3 over 3. That's my tan of negative pi over 6. Minus tan of pi over 4 is just 1. I move to my denominator. 1 plus the same answer up at top, root 3 over 3. And this is just a 1, so I don't really need it. This can then simplify into a full common denominator where I'm going to multiply those denominators up top, and I'm going to get root 3 minus 3 all over 3. So this is going to equal negative root 3 minus 3 over 3. And my denominator is going to be 1 minus root 3 over 3. I'm going to take it up here. When I have two numbers that share the same denominator, fractions on fractions, if they have the same denominator, I could just take the numerator over the numerator. It's going to be negative root 3 minus 3 over 1 minus root 3. That's not a 1, that's a 3. I have to multiply it. Now, from here, I multiply by something called the conjugate to get rid of the root in the denominator. Very, very common skill you're going to use in calculus and going forward in this course. The reason why this is the conjugate okay, so we know the conjugate to be like if I have 1 over root 2, 1 over root, let's use the root 3 over 3 actually. I use my special triangles, I get 1 over root 3. Why does my calculator give me root 3 over 3? Because it multiplies by a variant of 1, root 3 over 3 is 1, that gets rid of the denominator being a root. Because it squares the denominator. It squares it. Can't have roots if it's a square. So the top is just root 3 over 3. So that's why we have root 3 over 3 in a calculator. Well, the same can be true when you have a binomial. Instead of having this, I'm going to multiply it by something that forces a difference of squares. If I use the same one, the middle term is going to be like 2ab, and it's going to have a root for a perfect square trinomial. So I use difference of squares, so I take this squared, I take this, I square it, and I subtract. Roots are gone, guaranteed 100% of the time. So by doing this, I'll show that extra step over here. Brings me there. I multiply my numerator. Now my numerator becomes more complicated, but we're not too concerned with that. But my denominator becomes a 6. That's really easy. So my denominator is a 6, and my numerator needs to be expanded using whatever method you want. This is going to be a negative 3 root 3, a negative 3, a negative 9, and a negative 3 root 3. I'm going to collect my negative 3 and my negative 9, call it a negative 12 in the front. My negative 3 root 3 and my negative 3 root 3 is a negative 6 root 3, and it's over 6. Last step, let's go this way. They all have a 6, so I'm going to divide every single thing by 6. You can factor out a 6. I don't have the space to do that right now. So if I remove a 6 from everywhere, this becomes a negative 2 minus root 3 over 1. So this is my final answer. Okay, so just like we go forwards in math, we go backwards as well. We look at the right side of these formulas on this side, and we say, can I represent this using a shorter expression? Something that is equivalent, but way more simplified than this disaster. I'm not going to do compound angle formulas for all these 12s. That would be insane. If you're thinking that something's going to be insane in math, it's probably the wrong way to do it. Got to do some other way. So I'm looking here. It's a cos with a sine with a plus sign. Cos, sine with a plus sign. This is cos of A minus B. So I'm just going to go here, and I'm going to write cos of A minus B, just to kind of summarize my findings onto my question sheet. I know that the A value is the first number, and the B value is the second number, so I can go right into my cos of A minus B. I can now subtract that into a 2 pi over 12. This reduces to a pi over 6, and this just equals root 3 over 2. Okay, so I looked at what formula this can be represented as. It is the compound angle formula of cos of A minus B. I've substituted my A and my B value. I did the subtraction because it was available to me. Sometimes it's not available if I have like variables that are different, way more complicated than what we're going to see right now. My 2 over 12 reduces to 1 over 6, and now I'm finally in a position, cos of pi over 6, this is really easy, special triangles, root 3 over 2, done, simplified. Okay, you might see questions like this though, where you're going to have variables in your question. Easier. What's sine of x? Sine of x. I don't have to do any thinking. Variables are easier. It's less work. So I'm going to look for sine, cos, and cosine. Doesn't really matter if it's cosine, but sine, cos, cosine with a subtraction is sine of A minus B. Have your formulas handy right next to your work. Don't be flipping pages to look for formulas. Waste of time. Right next to you. Sine of A. This is sine of 2x. Oh no, sorry. I'm going to go right into that. Sine of A minus B. This reduces to sine of x. There's nothing else I can do there, so I'm done. I've changed something that looks like this to something that looks like this. They're equivalent. Of course, this is better. So if I ever have a question, I see this, or an identity, I'm working through an identity, I can just change that into a sine x. Save ink, save time, save paper. Okay, one more. We want to evaluate sine of A plus B, where A and B are obtuse angles, so that's pretty important that it says obtuse angles. This means that it has to be greater than 90, the angle. It's obtuse, can't be in the first quadrant. It also tells me that sine of A is 3 over 5 and sine of B is 5 over 13. So if I'm doing A, I know that sine of A is 3 over 5. Okay, sine of A is 3 over 5. Before you even think about that, where's the question? The question is not written down properly. Oh no, it does. Find this. Evaluate sine of A plus B. So I need to find what sine of A plus B is. I don't know what sine of A plus B is because I only have sine ratios of A and B. I'm going to look at my compound angle formula for sine of A plus B. I'm going to replace this to sine A cos B plus cos A sine B. I'm going to replace everything that I know, which is the sine A and the sine B. This is a 3 over 5. This is a cos B. This is a cos A. And this is a 5 over 13. Okay, so I just replaced sine A and sine B because it's given in the question. It's given. To find cos A and cos B, I need the 3 sides to the triangle. For me to have the sine ratio means I have the opposite and the hypotenuse. I don't have the adjacent. And for cos B, I need the adjacent and the hypotenuse. So right away, I mean, I know this is going to be a I know the hypotenuse is going to be the same from my diagram over here because I need the adjacent. This triangle is the 3, 4, 5 triangle, so I can use Pythagorean theorem to solve for it, or just know a 3, 4, 5 triangle. So now my ratio is 4 over 5. But cos in this quadrant, because we're dealing with an obtuse angle, is negative. So I have to put a negative sign here. Now I got to do the same thing with the other angle. Sorry, is this A or B? That's wrong. That's cos B. Okay, we'll deal with B right here. It's the same scenario except with a B, and my hypotenuse is 13 and my opposite is 5. Okay, If you know this triangle too, this is a 5, 12, 13 triangle. Come up often, certain triangles, like 3 triangles that come up very often in math. Or 13 squared minus 5 squared, square root of that, done, when you subtract them. Pythagorean theorem, I'm not going to show you Pythagorean theorem. Cos of b is going to be 12 over 13, and also negative because it's negative in that quadrant. Okay, now the rest is just simplification. 3 times 12, or negative 12 is negative 36 over 65, minus 20 over 65, and this reduces to negative 56 over 65. Done. Okay. Given 2 ratios, guys, if you're ever given a primary trig ratio, sine A, cos A, tan A, you know all the ratios because you know 2 of the sides of a right angle triangle. Use Pythagorean theorem, find the 3rd side. Now you have sine, cos, and tan no matter what. It asks you for cos of A and B, no problem. You know the ratio. Because it says obtuse, you know it's in this quadrant, so you know all the cos ratios are going to be negative. You plug in the negative numbers, now you can continue evaluating sine of A plus B. Okay, and that's it for 7.2. It's a lot of information, but with practice, easy.